We'll wait for a few more minutes, but if others join, we'll start at 6:10. Okay. So let's start the session. So let's start the session. Today we will discuss about the week 11 lectures. I hope you guys have gone through the lectures, right? So in this week, what we have studied is about the drought, like what are the causes of drought, what are the classification, how we can classify droughts into several types, and then what are the causes for those kind of droughts, what are the consequences, how we can analyze that what kind of drought it is, whether it is a drought region or not. Then we have also seen about the drought management, how we can manage those drought situation and so on, right? So today in this tutorial session, we will go through those lectures on a summary basis, and then we will discuss about some of the assignment questions, which will help you to do the assignment for this week. So if you have any questions regarding the previous assignment, or if there is any doubt in today's tutorial, you can just ask me at that time. Okay. So with that, I'll share the screen once. And for better bandwidth, I'll switch off the video. Yeah. So let's start. Hello everyone. So today we are going to discuss about the week 11 lectures, as I mentioned just now, of the course that is Watershed Hydrology. I am Balram Shah, I'm the PMRF TA for this course, that is Watershed Hydrology, given by Professor Rajendra Singh in Department of Food and Agricultural Engineering at IIT Kharagpur. I am doing my PhD at Interdisciplinary Center for Water Research at IISc Bangalore. So with that, let's start. So before going to the questions, let's just discuss once as the introduction of drought. I'll switch off the presentation here. I'll try to. Yeah, I hope this is clear. Okay. So let's start with the what term drought. Anyone, can you tell me what is drought simply? Okay, so according to, let's say, IPCC's sixth assessment report, so according to IPCC's sixth assessment report, uh, drought is simply a situation or condition when it is drier than the normal condition. Okay. So here, what do I mean by normal condition? So we'll talk about the classification of drought in few minutes. So anything like, let's say, rainfall, start the drought with rainfall only. So if any deficiency of rainfall, if we call that as meteorological drought. We'll come to that. So if you consider a average value or a mean value for time, we call that average value here as the normal condition, right? So now, before going to the causes of drought, I'll discuss about the classification of drought. Now, drought can be classified into four. Can be classified into what all? First one is the meteorological drought. So, in whichever place you see drought kind of situation, or let's say in any paper you read about drought, the first drought or the onset of drought, even wherever you say, so onset means what? Onset means the starting of the drought, right? So the word onset means setting up something, so starting something, right? So if you see any situation where there is a deficiency of rainfall, so if I write just like that, it will be deficiency of rainfall for a region over an extended period of time. We call that drought as meteorological drought. Okay, so not only rainfall, so when we have talked about rainfall in previous lectures, like in week third or week fourth, and there we have talked that in meteorology, not only precipitation but temperature also plays a great role, and then other factors which can affect the rainfall. So any factor which are affecting the rainfall also comes into the picture, right? Yeah. So meteorological drought is when these meteorological parameters are going below its average value, like uh, rainfall or precipitation, then evapotranspiration, and so on. Okay. Now with this, if let's say now if you think it like this, that if rainfall is less than that of the average value or the mean value, then what will happen? Firstly, the rainfall is less. This means the precipitation which we are receiving is less, right? In that case, what will happen after some time? That will lead to less amount of water in, let's say, stream flow. As a stream flow in rivers, there will be less amount of water in ponds, lakes, in reservoirs. So this meteorological drought will lead to hydrological drought. Okay, so with hydrological drought, we say whenever there is a deficiency of hydrological components such as stream flow or runoff, let's say stream flow or runoff in the river, then groundwater level, let's say, okay, in reservoirs or dams, if the storages becomes less. So any hydrological component, if it goes below the normal value or average value, we call that drought as hydrological drought. Okay. Next comes the, now let's say, some in some papers you'll see this, the third one that I'm showing as the second one, and then the third one. But let's say I'm going by the sequence. So if rainfall is getting less, then what will happen? It will affect the rivers, storages, groundwater levels, and so on. Right. Now this will lead to agricultural drought. So when any kind when this deficiency of rainfall or this hydrological drought If it affects the agriculture or the crop yield, if it causes stress in plants, in the crops, we call that as agricultural drought, right? So in agricultural drought, what will happen? So let's say if you see the soil moisture of the any region, then what will happen? The soil moisture of that region will become less, right? Next comes the socio-economic. I'll write this. It will affect the crop yield. Okay, soil moisture, so on. Next comes the socio-economic growth. Now, if let's say the agriculture of any country or any region is affected, this means what? You see, most of our country is agricultural region, right? So we thrive based on this agriculture. Now, if the agriculture only is having, if the crops that we are producing are not that much, then it will directly or indirectly affect the society and the economy of our country, right? And hence we will face a situation called socio-economic drought, right? So these are the classification of the drought, right? So drought, is a natural phenomena, and it represents a relevant temporary decrease in the average water availability, right? Now, if you see, let's say in India, you will see around 16% of the total area is a drought-prone region, starting from the Luni River basin in Rajasthan, then in some part of Gujarat, then let's say those are the arid part. Then comes the semi-arid part like Kaveri or somewhere in the Marathwada region in Maharashtra and so on. Okay, so almost 16% of the total area of our India is face this is a drought-prone region, whereas the 68% of the total agricultural land can be drought affected. Okay, so because of this agricultural drought, what we face, as I said, we face the socio-economic drought. And you will see, if based on the UN disaster risk reduction in 21, there was one report. Based on that, the India's GDP has reduced by 2 to 5% between 1998 and 2017, just because of this drought kind of situation. Okay, and if you see recent trend in 2020 to 2022, there was like almost two-thirds of the country was suffering the drought kind of situation. Okay, okay. So now we'll move to the causes of drought. Can you guys tell me like what are causes can be there which will lead to drought? Firstly, anyway, we have told first and foremost is the deficiency of rainfall. So we don't have input as in the water that we are getting. If we don't have that, by some means we are going to face the drought. Right? Anything other than that? Uh, So we mostly depend on the rain-fed agriculture, right? Dependency of rain-fed agriculture. So as we are very much dependent on the rain-fed agriculture, as mean the agriculture which are the agriculture or the crops which are mostly driven by the rainfall that we receive. So most of the crops that we have, if we don't receive proper normal amount of or average amount of rainfall, we see that we face agricultural drought kind of situation. So why I explained the classification of drought first, so that you can understand that which cause is creating which kind of drought, right? So this dependency on the rainfed agriculture can contribute to the region to be susceptible to drought, and several factors related to this dependence can aggravate the situation of the drought. Okay, so this insufficient rainfall during a drought can result in a lack of water for crops, leading to reduced yield of, or so right, reduce crop yield, or sometimes the crop failure, or crop failure. So this will lead to agricultural drought. Next, anything else? So these are the kind of deficiency of rainfall. We can't do anything. Most other than that, there are several human causes also. The very basic, or the very the first thing that comes to your mind when you we talk about human causes in the drought will be what? Will be the over exploitation of the groundwater. Right? If you see the northwestern part or northern part of our country, you see that like from maybe more than decades and all, you see there are over exploitation of groundwater. Right? So the groundwater is getting extracted in a increasing rate. It is around 2 to 5 millimeter per year. Right? So what we are doing, we are the human are doing excessive pumping of groundwater, which can lower the water table. And you remember then we talked about the groundwater level, or you can say the water table, right? So all this will lead to hydrological drought. So a lowered water table will impact the availability of water from wells and surface water bodies, which will lead to drought kind of situation. Okay. Next, other human causes can be land use, land cover change, right? So when we were talking about the conservation and all, like watershed conservation, watershed management and all, we talked right that if we let's say if a forested catchment is there, now if you remove the whole forest, and if you just keep it like bare land only, in that case also the capacity of the forest will reduce from 20 to 40% of the water availability. Right. So if you do, let's say, desertification or deforestation, you will see that the capacity of water that was there, like let's say if deforestation is there, it will disrupt the natural balance of the ecosystem and influence the various components of the water cycle. Other than that, there can be desertification, right? Desertification means what? That the process by which fertile land becomes increasingly arid and unproductive. So let's say if you're doing desertification, this means what? That there is a fertile land and you are using it at such level that it becomes unproductive, and it is also becoming arid. Okay. So when, let's say, if a fertile land is there and when it becomes infertile or unproductive, when we are talking about watershed management, in that you remember that we have told that we can change the crops in every year. So yeah, so there is one term called monoculture. What do you mean by monoculture? The word mono means what? One, right? So if you only sow or only harvest one crop every year, so let's say for 10 years you are sowing one crop only, let's say rice. So what will happen if you don't change this uh, one crop every year? Like let's say 2 years you're doing one crop, and then another year you are changing that crop to, let's say, sugarcane, and then again you are coming to the same crop. Then it's fine. It will have some management in the water that we have studied. We are not going deep into that. So practices such as monoculture or excessive use of irrigation or poor soil management, it can, what it can do, it can degrade the soil quality, it can reduce the ability to retain water, and hence it can create issue like infertility in the soil. Okay. So these kind of soil degradation and all will also lead to drought kind of situation. Other than that, we have overgrazing. So it's not, it doesn't affect much, but okay. Still, overgrazing is one of the part when the vegetation is excessively consumed by the livestock. it creates like excessive removal of the plant cover, including grasses and other vegetation, and hence it reduces the ability of the land to capture and retain water, and hence because of this, the soil moisture reduces and it creates drought kind of situation. Okay, so not only overgrazing, but if you do over cultivation over a region also, it will also lead to uh, drought kind of situation, right? So over cultivation, what do I mean by that is, let's say if you do continuous agricultural activity on the same piece of land, right, with the same crop, let's say, then it can contribute to the causes and aggravation of drought in several ways, right? So if you do continuous cultivation you do, but if you do without proper nutrient management, it can, as I said, it can deplete the soil fertility, right? And exhausted soils are less able to support healthy plant growth, and which will lead to less vegetation cover, and the impact of drought will be more. Okay, so these are the causes of drought. So these droughts, let's say, impact of drought, if you see, why we are studying this drought this much, because we know that is a natural disaster first of all. Second of all, if let's say we don't hear about that, the agricultural drought that we are facing, most important part, you will see that there is diminished crop growth, or there is some yield reduction, right? So this can happen. So while studying about the causes only, we have talked about this. Next, there are several small. I mean, not small. It's a big only, but let's say you will see dust storms. Also, if let's say if heat waves and all are there, it can also increase the probability of getting a drought, and it can worsen the situation when, let's say, drought is there and heat waves are also there. In that case, also, if you see, it will worsen the environment. It will worsen the situation. Okay, yeah, I was talking about dust storm. What is dust storm? Or let's say a dust bowl. A dust bowl is a region when, let's say, severe dust storm is experienced due to the combination of prolonged drought, soil erosion, and poor land management practices. You see in those region, mm, uh, dust storm, there will be everywhere. Dust would be there with high wind and all. Okay, so the finer particles of the soil are transported over large areas, creating dusty conditions associated with dust storms, right? And this dust storm will do environmental hazard. Also, our human health will deteriorate. Also, the infrastructure will have issues and all, right? Other than that, if a prolonged drought is there, we'll have famine situation. If you have read about West Bengal, there was a huge famine in the last century, right? So it is a situation in which large number of people have little or no food, and many of them die, right? So that is a like devastating kind of situation. Okay, so when the food production availability and access, this hampers, it will lead to widespread hunger and malnutrition, and this can cause several like consequences, right? Other than that, there are habitat damage. So all these are explained properly in the thing. I am not going into detail. Human health. Also, let's say if a area or if a region is a uh, say is facing prolonged drought, what will happen? Most of the people from there will shift from there to some place where there is no drought kind of situation. Hence, there will be mass migration of people. So wherever proper food and proper water is there, people will shift to those areas. Okay, and also it will affect the industrial and domestic purpose. because of the shortage of water. Because water availability will be low, and hence both the industries or domestic use will be there. Then we'll also have fight over natural resources such as food, food and water and so on. If you see Kaveri River, there was one dispute between Tamil Nadu and Karnataka. If you see again in Afghanistan side, there was a dispute between Afghanistan and Iran. So there are several when there is this kind of situation like country situation is there and there is dam in between. Some you will see when this kind of kind of situation arises, you will see there is a dispute or fight over these uh, situations, right? So these are the impact or consequences of drought. So this is there any question? If not, we'll do some questions first and then I will come back. Okay, so the first question is total drought prone area in India is approximately how much percentage? Anyone? So we have seen that total drought prone area in India is approximately 16% of the total area, right? And 68% was the total agricultural, and 68% agricultural land is drought prone, right? So the correct answer is A. Next question is, in India, a meteorological subdivision is considered to be affected by moderate drought. Okay, if it receives a total seasonal rainfall. Okay, first we have to discuss this and then we can come back to this. Fine. So anyway, we have talked about meteorological drought, right? So if you see the meteorological drought, drought. So several organizations or several papers, if you go through, there will be a slight change also in the classification of meteorological drought. But generally, what you see if the we'll write the total seasonal rainfall, total seasonal rainfall classification. Okay, so if the total seasonal rainfall is less than 75% of the normal value, again remember that I told that with normal I say about the average value. If it is less than 75% of the normal value, we call that as normal drought. Okay, if it receives a total seasonal rainfall between 26 to 50% of normal, we call that as moderate drought. Okay, if it is sorry, this will be greater than 75%. And if it is less than 50% of the normal, we call that as severe drought. Okay, so here the question was a meteorological subdivision is considered to be affected by moderate drought. So when we have moderate drought as per this classification, moderate drought when we have 26 to 50% of the normal, the total seasonal rainfall is around 26 to 50% of the normal value, we call that as moderate drought. So the correct answer will be B, that is 26 to 50% of drought. Okay. Okay. So next question is deficiency of rainfall from the average over an area for an extended period of time is classified as. So it's simply the deficiency of rainfall from the average over over an area for an extended period of time. It's classified as, so it's simply the deficiency of rainfall, right? So it will be which one? Anyone? It will be meteorological drought. So the correct answer will be A. Sorry, correct answer will be D. Right. Okay. Next question is, an agricultural drought can occur if there is early onset of the monsoon. There is no gap between rainfall events during the season, early withdrawal of monsoon, or sudden heavy rainfall. So let's go one by one. First is early onset of rain or monsoon. So onset means what I said. Early onset means early starting of the monsoon. So let's say if monsoon starts earlier than expected or the average month whenever it starts. So what will happen? We'll receive more amount of rainfall, and hence there will be no drought kind of situation, right? Or the chances are very less, right? Next is, there is no gap between rainfall events during the season. So if there is no gap between the rainfall events during the season, this means what? We are receiving a good amount of rainfall, and hence the there will be less chance of no chance of having the agricultural drought, right? Next is early withdrawal of monsoon. So let's say if the monsoon, let's say if uh, a region is having monsoon from, let's say, August to October, let's say, right? So that is the uh, normal months when we receive uh, rainfall for what particular region, let's say. Now you see that if it starts from August but it ends in, let's say, September end only, okay, then what happened, that we received less amount of rainfall than we are expected, right, than the average value, and hence it can lead to the situation of agricultural drought. And next is sudden heavy rainfall. So again, it is talking about heavy rainfall. If heavy rainfall is there, so there is a less chance of having agricultural drought. So the correct answer of this question will be C. That is early withdrawal of monsoon. Correct? Any questions still here? Okay. So the next question is, agricultural droughts are triggered by dash and hydrological drought. Okay. So options are climate change, reduced rainfall, meteorological, reduced crop production. So reduced rainfall, yeah, it's true that it will lead to agricultural drought. But again, I when I was talking about meteorological drought, I talked that it is not only the rainfall, but other meteorological variable also plays into the comes into the picture, like rainfall, then temperature as in evapotranspiration, and so on, right? So for this, agricultural droughts will be triggered by meteorological and hydrological drought. So the correct answer will be C. Okay, any questions here? So reduced crop production, it is itself the agricultural drought, right? So the question is like how agricultural drought will get triggered. Yeah. So the next question is, okay, so for this we have to just go through once. But before this, told something about meteorological drought and all. Yeah. So before going to the risk, we will talk about some terms. So the first term is drought year. So what is drought year? So if any area, let's say, is affected by moderate or severe drought, and let's say if it is to greater than 20% of the total area of the country, so what all we are considering here, we are considering the area. So let's say if the total country is facing, or let's say greater than 20% of the total area of the country is facing drought kind of situation, like moderate drought or severe drought, uh, the year in which that is happening, we call that year as drought year. Okay, 20% of the country is facing moderate or severe or let's say extreme drought. We call that year as drought year. Okay, and which one we call as drought prone area? So if the drought occurs in an area with probability, let's say greater than 0.2 and less than or equals to 0.4, so this is the probability of occurrence of a drought event. Okay, so for some area, if the drought occurs with a probability between 0.2 to 0.4 or greater than that, then we call that as drought prone area. Okay, so if the probability is greater than zero point 0.4, we call that as chronically drought prone area because it will have a severe drought kind of situation. Okay, so we call that as chronically drought prone area. Okay. Yeah, now we'll talk about the risk and all. So during flood, when we were talking about flood or runoff, we have talked about this risk and all. But again, we'll just skim through it. So we'll talk about drought risk assessment. But before that, we'll talk about the risk. So what is this risk assessment? Risk assessment means the process to identify and quantify the drought situation and rank the vulnerability. Rank the vulnerabilities. Then we call that as risk assessment. Okay, so here you see we have talked about overall risk will be function of hazard, exposure, and vulnerability. Right? So what is hazard? Hazard is like the magnitude of one hydrometeorological deficit is there. We call that as hazard. Right? So for this we need the meteorological data, the hydrological data, the biophysical indicators and so on. Okay, this one was hazard. Now what is exposure? So because of this kind of hazard situation, so the amount of elements and assets which are subjected to these kind of drought hazards, we call that as exposure. Okay, so the whatever elements or whatever assets or anything which is getting affected by this drought hazard, we call that as exposure. What is vulnerability? Vulnerability means let's say some exposed elements which are uh, which are exposed to this kind of damaging effects of drought. The sensitivity of that elements to this damaging effect of drought, we call that as vulnerability, right? So like how much vulnerable one element is to this much of damaging effect of drought. Okay, so some element can have less sensitive, some element can be less sensitive to that, but some element can be more sensitive to that amount of drought event also, right? So the overall risk will tell you the potential damage and loss from the drought to a specific asset, right? So mostly we measure this in terms of probability value. So drought. So what I mean by drought risk here, drought risk is the likelihood of incurring damages and economic losses, right? So any elements which are having getting exposed to this kind of situation during and after a drought. Right? Any questions still here? So this means what? So let's say if higher risk is there, then will it affect the agriculture more or less? Obviously, it will affect more because it is higher risk, right? Now we'll talk about some of the characteristic feature. Okay, so we'll talk about the drought characteristics. So let's say if at some place drought happened, right? So now if you just plot the time series of the drought, okay, now let's say, so let's say if you plot the time series of the drought. So this is, sorry, whatever. Yeah, so this is in time. Let's say monthly data we are plotting, and let's say this is some indicator value. Okay, so mostly we use some indices. We have seen that in lecture, but just for here, we'll talk about SPEI. We'll talk about this SPI again. So SPI is Standardized Precipitation Index, which tells you about the meteorological drought. So let's say starting from maybe Jan 2000, we'll go till maybe uh, this is April 25, right? So let's say it's there. So there are several drought events that you can see. So let's say this is the zero value, and the index value is like 1, 2, 3, -1, -2, -3, something like that. Now you see that there are several drought events that happen. So anything we are considering that anything above zero, we are considering that as a normal situation. There is no drought, and anything which is going below zero, we are considering that as drought. So let's say there is several. Something like that. Just for example, I have plotted this, right? Now in this you can see several things, several drought characteristics, if you can see. So first thing is drought frequency. What is drought frequency? From the word frequency, you know that anything which is coming back. So let's say in oscillation you have studied about from frequency, right? So let's say if something starts from somewhere and again it comes back after some time, that time we call that as frequency. So what is drought frequency? So drought frequency is number of drought events per defined time interval. So let's say for 1 year, how many times the drought is coming again and again. So more frequent drought means what? That let's say for one time, for let's say 1 year, that 1 year 2 times drought has come. So you can say that more frequent drought is there, and so let's say if more frequent droughts are there, what will it cause? It will cause long-term impacts on the affected ecosystems. Okay. Next drought characteristic is the duration, drought duration. So let's say the total time for, so let's say this part, I'll change the color. So let's say this part, right? So here for the whole part you can see the index value is less than zero, and what I told that anything which is less than zero we are considering that as drought. So the total duration for this drought event we call that as drought duration. Okay, so how many months are there? That is considered as drought duration. Again, see here we have a small drought event. So here also the total amount of month that are there for that we call that as drought duration. This will also be considered as the total number of time or discrete value we consider, we call that as duration or drought duration. Okay. Next we have drought severity, or let's say drought magnitude. Okay. So drought severity means what? So let's say in this index, see, the index value has gone till, let's say, -2, and hence, so let's say -1, we are considering that this is a moderate drought. So if we consider this as moderate drought, -2 as, let's say, severe drought, -3 as extreme drought, something like that. So this will tell you that this index value or the magnitude value will tell you how severe is the drought, right? And how we calculate this severity value? Generally, we calculate this severity value SI as summation over the indicator. So let's say I'm like writing as drought indicator of the ith month minus the threshold. Okay. Okay. Next we have drought severity. Severity frequency. Okay, so let's say for the whole duration, if you want to ask how much severe is the drought, so what you will do, you will do the summation of all these indices. Okay, so that one will be severity. So let's say just note it like this. The total summation of all the magnitude in this duration will be considered as the drought severity. Then is the drought peak. So let's say for this drought event, this one, this one is the highest or the least SPI value, right? This is the drought peak. Okay, drought peak. Then comes the intensity of, intensity means what? Intensity means the severity divided by the duration. So this means severity of drought or drought severity divided by the duration of drought. Okay, there are several other features also, drought characteristics, such as deficit of water or the onset of water when it is starting, or the cessation means when it is ending, when the drought is ending. So all these are the drought characteristics, right? Then peak month, as I said. Then area, how much area is getting affected. That is also one of the drought characteristics. So let's say if a bigger area is exposed, then what will happen? The more assets will be affected, right? So what is area affected? Area affected means the percentage of a region with values of the drought indicator below a certain threshold. So in this case, let's say 0 is the threshold. So below that, if it is going for some area, we call that that area is affected one, right? So for drought risk assessment, what we are doing, mostly we define the scope and objectives, like we clearly define, okay, this region is getting affected, so we have to do something for this, including the boundaries and characteristics of the area under consideration. Then after we have defined this scope and objective very thoroughly, what we do, we or the government, what they do, not only the government, the organizations, the institutes also, they assemble a diverse team, multidisciplinary team that includes expert in several fields which are connected to this drought. So let's say meteorological, so experts from meteorology, experts from hydrology, experts from agriculture. So all these background, there will be a diverse team which will help each other to do this drought risk assessment. Okay, so they will collect the historical or observation data, and then they will do the analysis, and then they will come up with the inferences. Okay. And then so how they will do the analysis, they will identify which drought indicators is required for this kind of drought, how it is triggering. Okay, so they will define all the vulnerable sectors, and then after the analysis is done, they will start imposing that, like how we can do the drought monitoring. Okay, how we can create some early warning system, so that before the drought is going to hit, we can tell that, okay, drought is going to hit, and hence we have to plan something, or how we can do the planning and all. Okay, so monitoring systems, then early warning system, we have to conduct some susceptibility assessment. Okay, so like based on how much is the scenario. So let's say this time the scenario is going to be very like long term impact or something like that. Based on that, we'll do modeling or scenario analysis. We will also inform the community, social community, like not only the social community but the local communities, stakeholders, experts to gather local knowledge and understand community perceptions of drought impacts and incorporate some priorities assessment, like some assessment processes so that they can be out of the risk. Okay, then we do the risk mapping as I said, and early warning system and so on. So with this, we finish the drought assessment or the drought risk assessment part. Okay, and we have done with the hydrological drought also, right? So, so with that we'll do some questions and then I will come back here. Okay. So the next question is estimating overall risk in drought risk management requires. So we have just seen that estimating the overall risk is a function of all this, that is hazard, exposure. I'm writing it in a sequential ways, then vulnerability and so on. Isn't it? So the correct answer will be all of them. D. Right? Okay. So the next question is an area is characterized as drought prone if the probability of drought occurrence is between zero point 0.2 to zero point 0.4, right? And if the probability is greater than zero point 0.4, what we call that as? We call that as chronically, right? And if it is less than zero point 0.2, we don't consider that as drought. So the correct answer is A. Okay, so the next question is an area of significantly reduced rainfall on the leeward side or the side facing away from the prevailing winds of a mountainous region is called as, anyone? So when we talked about the, or we have learned about the meteorological drought, the causes of meteorological drought, there we also talked about the local topography and the geography, let's say. Okay, so there we talked about this, or the rain shadow effect. What is rain shadow effect? What is rain shadow? Rain shadow means an area of significantly reduced rainfall on the leeward side, or let's say the side on which the winds are not there. So the side facing away from the prevailing winds of a mountainous region, we call that area as rain shadow area. Okay, and hence rain shadow effect may lead to meteorological drought. Meteorological drought. Okay, so the area of significantly reduced rainfall on the leeward side or the side facing away from the prevailing winds of mountainous region is called as rain shadow. Okay, so correct answer is A. Any question here? Okay, we'll move to the next question then. Disadvantage of SPI. Okay, so now we'll move to the indicators first and then we'll come back. Okay, so the causes and all we are done with. Now to analyze this drought situation, because see, in flood, whenever we have talked about the high flows, right? And there we had a good amount of data that okay, we can see that also that see we are having a increase in the ground, increase in the water level, and hence flood is coming. But while this drought kind of situation is there, it's kind of, it's like something which is we have not seen, or something like an elephant in the room, how it went and something like that, right? So it's like so we can write it as low flow situations, low flow situation. So to do this, do analysis of drought, we use several indicators. So for each of the classification that we have seen, we have uh, several number of indicators or indices. Okay, so we talk about drought indices. So we'll talk about few of the drought indices. So it's not like whatever drought indices you have seen in the lecture or we are seeing here, those are the only drought indices. There are several other drought indices which are like which are advantages over others. But again, every drought indices will have its own limitations, its own advantages. So based on that, we should decide that which indices or which indicator we should use for that region, for that period of time, for the further analysis of the drought. Okay, so based on that we should use the drought indices carefully. Okay, so mostly for meteorological drought there are several indices like deciles of precipitation, we write this as DI. Then we have sorry, precipitation departure from normal, that is PDN. Then we have very frequently used, we have standardized precipitation index is SPEI, and again there are several other. Okay, so the, so let's say deciles of precipitation. How do you calculate? It's like you have the long-term data, let's say for 30 years. From there, you uh, arrange it chronologically in this ascending order. So you give rank to each rank. To, let's say the first rank to the highest one, and like lowest one to like final rank to the lowest one. So what do you do? The data is first ranked from highest to lowest to construct a cumulative distribution frequency curve. Okay, so we draw a cumulative frequency distribution, and then that distribution is split into 10 parts, let's say. So that's why we are having here deciles. Okay, so we'll divide it into 10 parts and based on like equal probability. So we know that total probability will be how much? Will be 1, right? So we divide that as 10 10 parts, so that each probability will have, let's say, zero point 0.1 probability each of the parts. Okay, now the drought severity is then characterized based on the deciles. For example, the lowest, let's say 20%, deciles 1 and 2. Okay, so let's say 0 to 20%, if it is decile value is there, or DI value is there, then we say that it is much below rainfall. Okay, if 20 to 40% is there, then we call that as below rainfall, and so on. Okay, you can just go through the lecture PDF. Okay, so what is the advantage of this decile precipitation? It's like the decile index will provide you accurate precipitation data for drought responses. It is more useful index because it assists decision makers to determine where financial assistance has to be provided in times of drought. But see, what is the limitation of this indices index? Anyone tell me? In the beginning only I told while discussing this DI that it requires a long-term data. That is, it requires a long climatology record. Okay, so let's say if you don't have like a long record, then we can't use this decile index properly. Okay, next is precipitation departure from normal. So uh, it's simply the so let's say how much uh, the rainfall uh, is. So let's say if average rainfall is there. Okay, so I'll write this as P naught minus P average divided by P average into 100 to make it as a percentage. So what does this precipitation departure from normal indicates? That uh, the meteorological drought as rainfall departure from its long-term averages. Okay, so this is the long-term average. Okay, and declares meteorological drought on a weekly or monthly basis. Okay, so if let's say if it is 0, so 0 means what? That the observed value is equal to the average precipitation value. So if it is equal, then we are saying, if it is greater than like 0, then obviously it is greater than average, then there is no drought. Okay, so if it is greater than equals to 0%, there is no drought, right? Now, as it reduces, so let's say if it is between 0 to minus 25%, we call that as mild drought. If it is minus 25% to 50%, we call that as moderate drought. And if it is more than minus 50%, we call that as severe drought. Okay, what is the advantage? That it is very simple. Just subtract from the long term average. You calculate the long term average from the data. You can subtract it from that and divide it that and into 100. So simplicity is there, right? But what is the disadvantage? That we don't consider any distribution or the time scale of rainfall, and hence we some places where like rainfall distribution is important, we can't use this in this index. Okay, next comes the standardized precipitation index, that is SPI. Okay, so you will see in the most of the paper for meteorological drought, basic one they use is the standardized precipitation index, right? So SPI is the most commonly used indicator. Okay, right. So in this, as I said, in the second one, that is PDN, the precipitation departure from normal, we don't consider any rainfall distribution, rainfall probability distribution. But in this, we consider the gamma distribution, right? Gamma distribution function use. We use a long-term record of monthly precipitation, let's say, and then we calculate the SPI value. And how do we calculate the SPI value? SPI for someone I month, it will be equals to P minus P average by sigma P. Okay, sigma P. Okay. So this is, what is P average? P average is the mean precipitation. Okay, and this sigma is the standard deviation of the data that we consider. Right? Okay, so several in many of the papers you'll see something like say SPI 1, SPI 3, SPI 12, something like this. So what does this number indicates? This number indicates that how many months you are considering. Okay, so it characterizes the meteorological drought on a range of time scales. These are time scale. So 1 month time scale or 12-month time scale, depending on what application you are going to use, you consider that time scale. So let's say on a shorter time scale, the SPI is closely related to soil moisture, where while at a longer time scale, the SPI can be related to groundwater and reservoir storage and so on. Okay, so what are the advantages of this? It can be computed for different time scales and it can provide early warning of droughts also. And what is the disadvantage? See here, you only consider the precipitation. So you don't consider any like temperature effects, that is the evapotranspiration and so on. Okay, so for that, um, there are other standardized precipitation, evapotranspiration index. We call that as SPE. Okay, so in this, both the precipitation and evapotranspiration effect is considered. Again, so here you have seen, right? So here, let's say if you are talking about SPI, if you are considering that as sorry, if you are considering this as one threshold, so if it is less than -2, we call that as extreme drought. Okay, if it is between -1.5 to -1.19 1.99, we call that as severe drought. Okay, if it is between -1 point, so you will have moderate drought. Okay, and then you will have mild drought, you will have no drought. You have this. So based on that, you classify the uh, drought. Okay, so these were the meteorological drought. So similarly, you will have several hydrological drought indices also. Right? So I will not go that much detail into all the hydrological drought indices. So what all we have studied? We have studied the standardized water level in this index. It is SWLI, right? Or we say SWI, sorry. Then we have surface water supply index, SWSI. Then we have reclamation drought index. It is RD, I think. We have stream flow drought index, and there are several other drought index which will tell you the situation of hydrological drought. Okay, so each will have its own advantage. Like if you consider the standardized water level index, it will compute different, can be computed at different time scales, and it can provide early warning. But again, see, it only takes the groundwater into account, right? It will only take the groundwater into account. The surface water will not be considered, and so on. Whereas if you consider the stream flow drought index, in that you are only considering the stream flow drought, but not the groundwater level, and so on, right? So each of these indices which will have its own like equations and so on that you might have seen in the lectures, right? Yeah. So we are not going to deep into that. Okay. Next comes the agricultural drought index. Now, for all these indices, like for meteorological drought, for hydrological, for agricultural drought, and all, these are like kind of statistical measures or kind of those kind of index. But other than this, because now we have the remote sensing data also, right? So we have several remote sensing based indices also, okay, that we might have seen in the lecture, right? So there are several agricultural drought indices. As we know that agriculture is what important to us, and hence we deal it many times. So there is aridity index. We call that as AI. Then I'll not write the whole thing, I'll just go through the lectures. Farmer drought severity index. Then we have moisture and humidity index. So if we need anything from in the assignment question, we'll come to it. Okay. Then we have crop water severity index. Okay, so these are the statistical measure from the observation data, right? Then we also have, as I said, remote sensing based indices like NDVI, which is very popular. NDVI we use to know the health of the vegetation, like how vegetation is and so on, right? Then we have transform vegetation index, enhanced vegetation index, vegetation condition index, temperature condition index, and so on. Okay. Okay. So we'll go to the questions first, and then we can come back if required. We are here. Sorry. Okay, so the next question is disadvantage of SPEI is. So we have just now discussed about the SPEI, right? What is the disadvantage of SPEI? So it can be computed at different time scales. So this is not the correct answer. It can provide early warning of drought. So it's fine. Does not deal with change in evapotranspiration. Correct. So it does not. It only talks about the precipitation. It does not takes into consideration the evapotranspiration part, and hence it is one of the disadvantage of SPI. And distribution, we have seen that gamma distribution is considered, right? And hence the correct answer will be C. Okay, so the next question is standard precipitation index, that is SPI again, based on the probability of precipitation and for any time scale with P as the precipitation of the station. P, okay, so this is P bar. Okay, here it is written as P bar. P bar in the town. P bar as the mean precipitation and sigma as the standard deviation. So we have seen we can write SPI as P minus P bar here divided by sigma. The correct answer would be B. Right? Okay. Any questions still here? We'll move to the next question then. Which one of the following is not a drought characteristics? Okay, we saw that duration is one of the drought characteristics, frequency is one of the drought characteristics, severity is one of the drought characteristics. So all of these are drought characteristics. So none of this are not a drought characteristic, right? So the correct answer will be D. Okay, so the next question is which one of the following is not used as hydrological drought index? We have seen reclamation drought index we consider for hydrological drought index. Stream flow drought index also we consider for hydrological drought index. Surface water supply index. This SPEI we consider for the meteorological drought index, right? So this is not for hydrological drought index. So the correct answer is C. Okay. Now the next question is population growth and poor water management can lead to whatever. Population growth and poor water management can lead to. So if there is a huge population growth, what can happen? So these see this agricultural drought, meteorological drought, hydrological drought. These all are mostly the um, based on the natural variability or something like that. Okay. Now if you do poor water management, it can lead to agricultural drought. But again, here it is mentioned that both the population growth and poor water management. So it will lead to mostly socio-economic drought. So the correct answer would be A. Okay. Okay. So the next question is the aridity index, where AET and PET are the actual and potential evapotranspiration, is given as. So in the lecture you might have seen that we are writing A is as PET minus AET divided by PET into 100. Right? So this is the numerator is the residual energy and PET is the maximum energy that the region have to evaporate. Right? So this one will be the correct answer. But again, if you see different papers, this aridity index can be defined into several other form also. So somewhere you will see it is defined as PET by P, where P is the precipitation. Somewhere you will see AI as P by PET, but somewhere you see this as humidity index also. Okay, so several researchers use in several other forms. So for our this question, the correct option is option A. Okay. Next question is utilizing the information from the lysimeter, find the aridity index once a week with the obtained aridity index value. Tell that which week has the experienced mild drought. Okay. Can you just do it once? Okay, just for your reference. Like if AI value is less than 25%, less than or equal to 25%, we call that as mild drought. If it is 26 to 50%, we call that as moderate drought. And if it is more than 50%, we call that as severe drought. Okay, you can just calculate this. See, we have, let's say, week numbers, AET and PET values. And how did you calculate AI? We have just seen in the previous slide, that is PET minus AET by AET into 100. Right? I'll give few minutes, 2 minutes for this. You can just do this. Just complete the question first. 5, 6, 2, 5, 3, 2. And see here, PET is the maximum energy that can maximum evapotranspiration that can happen for a region, right? And hence PET cannot be any time less than AET. It can be like equal to or it can be greater than the median. Hence, the AI value or the activity index value will always be positive. Okay, I'll give you 2 minutes for this. Just do this and let me know which week is experiencing mild drought. So I got something like 23%, 28.6%, 35.7%, 40%, 25%, 31.3%. So see, most of the AI value lies in 26 to 50% value. This is in 26 to 50. This is also 26 to 50. And then this is less than or equal to 25. So this week has experienced mild drought. Right? So week 5 has experienced a mild drought. So correct answer will be D, that is week 5. Any question here? Okay. Okay, so the next question is the moisture anomaly the moisture adequacy index for depicting the agricultural drought was developed by, might have seen in the picture. So what is this moisture adequacy index first? Moisture adequacy index, or MAI. It is the, how do you write it mathematically? MAI is equals to is the ratio of actual evapotranspiration to the potential evapotranspiration. Okay, so this is how you do it. So it is a fraction, right? So if you just want it in percentage, you can just multiply it to 100. Okay, so it was developed by ICAR, that is Central Zone Research Institute. Okay, so the correct answer would be B for this. So this MAI is computed during different phenological stages of crop using weekly water balance. So using weekly water balance. So the main advantage is that this is a better measure for assessing the degree of adequacy of rainfall and soil moisture to meet the potential water requirement of crops. Okay. Okay. So move to the next question. Next question is okay. Next question is the moisture adequacy index, where AET and PET being the actual and potential evapotranspiration is given as. Just now we have seen, right? That it is the ratio of actual evapotranspiration to precipitation. Sorry, actual evapotranspiration to potential evapotranspiration into water. So the correct answer will be A. Okay. Any questions? Any question? Okay. Not, we move to the next question. So next question is, if the moisture adequacy index of a particular area is 58%, then what should be the drought condition of that? So if you just see, drought class for MEI value percentage is classified as. So let's say if it is, see here, the moisture anomaly index is defined as how? It is the ratio of actual evapotranspiration to potential evapotranspiration, right? And what I said, that actual evapotranspiration can vary from 0 to potential evapotranspiration, right? So the MAI value will always be between 0 and 100, correct? Now if it is less, that is if actual evapotranspiration is less, this means what? Compared to the potential evapotranspiration, it will be just okay. It is like it's a 76 to 100%. It is no drought. If it is 51 to 75%, it is mild drought. If it is 26 to 50%, it is moderate drought. If it is 0 to 25, it is no drought. Sorry, severe drought. Okay, now here it is mentioned that it is 58%. So 58% lies in this group, and hence the correct answer will be mild drought. Okay. Okay. So the next question is related to crop water stress index, that is CWSI. And how do we define CWSI? CWSI is for particular crops generally. So it's like you consider the time period of planting or sowing to harvesting. 1 minus TA by TP into W seasonal coefficient. So what is TA? TA is the actual crop transpiration. So here mostly we are doing for canopy or crops, right? So it could be millimeter per day obviously. So here you see only consider the transpiration part, and obviously TP is the potential crop transpiration, also in millimeter per day. And what is this WSUS? WSUS is the weighting factor, which depends on the season. Okay, weighting factor for grain yield susceptibility. Okay, so with this you can calculate the CWSI value, right? So these values are the daily integration of plant available soil, water, evaporative demand, and plant phenological stage, like if it is in young stage, old stage, middle stage, or something like that. Okay, so mostly the soil, plant, air, and water model is used for the simulation of soil, water, and calculation of effective rainfall for plant transpiration. So can you just do this? Because see, you have the, so here we are considering the actual crop transpiration as the actual evapotranspiration only, and potential crop transpiration as potential evapotranspiration. And if I'll give the classification also. So if CWSI is 0, that is the lower boundary, we consider drought, or if it is 0 or near to 0, let's say if less than 0.5, we consider that as extremely wet condition. It means no, okay, right, extremely wet condition or no stress situation, no stress or no drought kind of situation. And if it is 1 or near to 1, we call that as extremely dry situation or no transpiration situation. Okay, just use this and take the summation. So weighting factor is given as 0.8. Yes, CWSI will be equals to 0.8 into 1 minus T by T. T is how much? 2.5 by 3.5 plus 0.9 into 1 minus 1.8 by 2.5 plus 0.7 into 1 minus 1.2 by 2.0. Can you just calculate this and tell me the value, how much you are getting? Give you 1 minute for this. I am getting somewhere near 0.76. Okay, and now you see this 0.76 is near to 1, right? And hence the crop is extremely dry. Okay, so the correct answer would be A, that is 0.76. Okay, I hope you guys got the same answer. Okay. Okay, so the next question is NDVI stands for. So as I mentioned that NDVI is one of the important remote sensing based agricultural drought index where you can see that how much is the vegetation and how much lush green it is and so on. Okay, so it is like a numerical indicator that uses the visible and near infrared bands of the electromagnetic spectrum. So we are not going to electromagnetic spectrum because if you might have studied the basics of remote sensing now, you might be knowing what is electromagnetic spectrum of physics also you might have seen. Right. So the full form of NDVI is normalized difference vegetation index, that is C. Okay. So anyway we have this formula anyway. So how do we calculate NDVI? NDVI is, as I said, it considers the visible and near infrared bands, right? So NDVI is calculated as the ratio of the difference of NIR band minus the red band and NIR plus red band. Okay, so where NIR is near infrared, band, or we take the reflectance value from here. Okay, and R is the red band. We take the reflectance value of both. We do this subtraction and addition. We take the ratio of it, and so see, if you see this equation, you can tell that how much will be the what will be the range of NDVI. Anyone? Can anyone tell that how much will be the range of NDVI? So the range will be between -1 to 1, right? Correct. So if like it is near to 1, we say it is like no drought situation is there or optimum situation is there. But whereas if you go near these negative values, we call that drought situation is there. Okay. So the correct answer for this will be NDVI can be calculated as NIR minus R by NIR plus R, right? Others also, if you would have seen, this is that DVI, that is, this is also differential vegetation index and so on. Okay. Okay, so we'll see the next question. Any question here? No? Okay, we'll move to the next question then. Calculate the NDVI ratio and comment on drought for reflectance of red and near infrared light as 0.08 and 0.15 or 0.55 respectively. So NIR band we have 0.55 reflectance value, and for red reflectance value is 0.08. Okay, how do you calculate NDVI ratio? Simple. And you have to comment on the drought also, right? Okay. So NDVI will be equals to NIR reflectance minus rate reflectance NIR and plus R. So it will be 0.55 minus 0.08 divided by 0.55 plus 0.08. I'll give 1 minute for this. Just calculate this and tell me how much you're getting. Then I'll write this NDVI value and the class of drought. So if it is less than or equals to minus 0.2, severe drought. If it is between minus 0.2 to minus 0.05, we call that as moderate drought. If it is between minus 0.05 to 0.1, we call that as near normal, and if it is greater than 0.1, we call that as above optimum. So above optimum means the vegetation is healthy and all. Okay, yeah. Did you guys get the value of NDVI in this question? It will be somewhere 0.7 or something. Yeah. So we are getting somewhere near 0.74, and hence this 0.74 is very much greater than 0.1, right? And hence it is above optimum, and hence there is no drought. So the correct answer will be B, right? Any question for this? Any question for this? We'll move to the next question. So next question is long term, that is 25 years maximum and minimum NDVI for August are 0.75 and 0.03. The average NDVI for month is 0.35. Calculate the vegetation condition index. So how do we calculate vegetation condition index again? Vegetation condition index for some month is calculated as NDVI of that month minus NDVI minimum divided by NDVI maximum minus NDVI minimum. So this again is then a percentage, in fraction value. So if you want to get in percentage, you will just multiply into 100, right? Just put, so again this NDVI I is the NDVI I for ith month or the week. Okay, you just calculate and tell me how much you're getting. So here I is what? I is the August month. Like 0.35 minus 0.03 divided by 0.75 minus 0.03. Just calculate this. I'll give 1 minute for this. Till then I'll write classification. So this is in percentage. It is less than 10, and the extreme. It is between 10 to 20. Severe. It is 20 to 35 is moderate. Between 35 to 50 more drought. It is greater than 50 and it is wet or no drought situation. How much you got in this? Can anyone tell? I'm getting somewhere near 24.44%. Yeah, so it's near to 44.49, right? So the correct approximation is B. I hope you guys got the same answer. Now, yeah, so let's say if I asked you to comment on the drought condition, this is between 35 to 50%, right? So there is no drought situation in this area for August month. Okay. Okay, let's move to the next question. So the next question is the main impact of agricultural drought is on agricultural drought. Okay. The main impact, the water cycle imbalance is the main impact from meteorological drought, right? Then this reduction of water supply is due to is the cause of which drought? Which kind of drought? We just have seen, right? It is the cause of hydrological drought, right? Reduction of crop yield is the main impact from agricultural drought. And implementation of afforestation techniques. Okay, so if afforestation techniques we put nice techniques, then it will help in mitigating the risk of agricultural drought. Right? So anyway, this is not the impact, but this is one of the techniques to mitigate the risk of droughts. Right. So how do we do this water cycle imbalance? Like how do we uh, modify our method to deal with all this? For now, for this question, the correct answer is C. Right. So we were talking about water cycle imbalance, right? And this water cycle imbalance is due to meteorological drought, right? So deal with this. We have several methods or several techniques like cloud seeding is there. So what we do in cloud seeding, in clouds, like what we do, we change the amount or type of precipitation that falls from the cloud. How do we do that? We disperse some substance into the air that serve as cloud condensation. Okay, cloud condensation or ice nuclei, which alter the microphysical processes within the cloud. And with that, what happens? The amount of precipitation that cloud can happen will be more because we are imposing the like imposing the cloud to get condensed, and we know in the very beginning of this course we have studied that if the cloud get condenses, precipitation will start forming, right? So for this cloud seeding, most commonly used chemicals we use is the silver iodide. Okay. So other methods are evaporation control. So you might have seen like we do mulching for agricultural drought and so on. So others are also there um, for covering the lake or pond when evaporation is more. What we do, we cover that lake with one chemical, right? So that also we can be done using as evaporation control. We do afforestation and so on. Okay, so the question was the most common chemical used for cloud seeding is this. You might say, right? The correct answer would be silver iodide. Other than that, we also use potassium iodide. Right? We also use dry ice as in the solid carbon dioxide. Right? So the correct answer for this will be silver iodide. Okay. Then what was that? Hydrological reduction of water supply. How we do? We generally do water harvesting, right? For agricultural drought to impact, what we do? We go for water harvesting. We go for micro irrigation, macro irrigation. Then cropping pattern we change. Remember, while we were talking about the watershed management or soil conservation techniques, we have talked about the contour burns or several agricultural practices, irrigation practices, how what we can do to reduce the impact of the soil erosion and agricultural drought and so on. Right. So all those things also we can do it here. Okay, rainwater harvesting. Then for agricultural drought, we do spreading of water over the command area. Storage structure we build like check dams, nala dams, and so on. Nala dams and so on. Right. Okay, so the next question is one of the management technique for mitigating the risk of hydrological drought is your cloud seeding. We have seen this is for the meteorological drought. Community awareness is for socio-economic drought. Evaporation control is again. Uh, yeah, it is one of the technique, but mostly used for meteorological drought. For now, for in these two, the water spreading burns will be like more apt, right? Because water spreading burns. So if you will see, so let's say this is the river, and what do? You take this water into some area, you do some slope here, so that water can flow here. Now there will be one step here, okay, and then the slope will be in this side, and the water will flow through. It will go here, and then again it will flow like this. Again here there will be like this, and the flow will be like this. Then again it will be like this, like this. So what we are doing? We are spreading the water area, right? So with this we can use the water properly. Water spreading buds here you can see are the used to spread the flood water which has either been diverted from a water course or has naturally spilled onto the floodplain. Right. So the correct answer will be water spreading buds. Okay. So the correct answer is A. Any questions here? I think this is the last question. Yeah. So do you guys have any doubt, any questions? If not, we'll stop here. Any questions? Okay, if not, we'll stop here. Thank you. Again, we'll meet next. So next will be the last tutorial sessions which we will have, right? Okay. So we'll meet again on Monday, 6 o'clock.